Okay, so two session I have already taken regarding this manufacturing. So you can watch those recording session also. So till now I have discussed the concept related to the casting as well as the metal forming operation, rolling, and what we call as a deep drawing, that sheet metal operations also. So one more important concept which is related to the sheet metal operation. So Jagan, you are attending from this session. So let me first explain. In case of sheet metal operation, what you are doing, actually, this is the sheet metal. With the help of punches, with the help of punch, you can shear off this particular material. Okay, that means the shearing action is going to be happen. Shearing action is going to be happen, but that whatever the forces which you are applying, that will be the maximum force. That means if you want to calculate the work done, the force into displacement, how much penetration is happening in the sheet metal. So F max into KT is nothing but the work done only. But when we will provide the shear over this punches, what will happen? The force will get reduced. The force is getting reduced because this point is coming in contact with the sheet metal, and there from here itself the fracture will start. Okay, the shearing action will start. So once this point will reaches here, this point will reaches here, because this much amount of penetration you want to remove the amount of material. Okay, so once it is reaches here, then we can say that the punching can be done, because for punching this particular sheet metal of having a thickness T, only the this much amount of penetration is sufficient. So if you are providing the shear, the force is getting reduced. The force is getting reduced. That means one other has to be increased, which is nothing but the stroke length. That's why I mentioned here, by providing the shear, the punch load can be reduced, but the stroke length value will be increased. That means this value will be increased. But the total work done, the force into this displacement and this force into displacement will be same only. So in the case of F max into KT, this is the constant force which you are applying. That is nothing but the work done. But in this case, this force you can calculate by equating their work done. So F max into KT is equal to F into KT plus S. Now you can see here, this is the penetration and this will be the shear which you have provided to the punch. Okay, so this is the stroke length. Now in this stroke length is KT only, but stroke length here is S plus KT. So stroke length is increased, force is getting reduced. That means less force are sufficient to do the this cutting operation, which is nothing but the punching. Based on that, the gate has asked one question, which is in the 2004. What is the question? So 10 mm diameter hole is to be punched in a sheet of 3 mm thickness. The shear strength of material is given. Penetration is given. So always remember, the penetration will be given in the percentage. Okay, so it is given as a 40%. That means 0.4 times of the thickness. Always the penetration is corresponding to the thickness. You can see here also K into T. So 0.4 into whatever thickness of sheet metal. Now the shear is provided on the punch is 2 mm. Okay, so if you are not providing the shear, that means you know already the force into this penetration into thickness will be the work done. But with the help of shear, the force is getting reduced. Okay, that you have to calculate. The blanking force during this operation will be, the four options are given. Okay, how you will solve? First of all, you will calculate the maximum force. The maximum force is nothing but, just one second. The maximum force is nothing but the shear stress into area. What is the shear strength? Shear strength is 400 Newton per millimeter square. That means this value is given as 400. What is the shear area? You know that hole you are creating, that means shear area is nothing but penetration, the perimeter into thickness. Perimeter into thickness. So what is the perimeter? Perimeter is nothing but pi d into T. So this is nothing but 400 into pi into d into thickness. What is the diameter given? Diameter is 10 and sheet thickness is 3. What is this value? 400 into 12 into pi. Can you tell me, Jagan, what is the value you are getting? This force value. I hope you have the calculator. So do it fast. No need to write down all the notes, because already we'll get the recorded session.
Good evening, sir. can you show me this question one, sir, which you are presently discussing?
Okay. Just now you joined?
Yes, sir. So till now, what happened in the class, sir? This question only.
Yeah. This from here only I have started. So whatever I have discussed in the previous class, I think you attended, Raj. The force you can calculate F max into KT divided by S plus KT. This based on this formula, I am discussing this particular problem. What is the problem? You are creating a hole to be punched in a sheet metal. Thickness is given. Shear strength of material is also given. Penetration is given. Now the shear is provided on the punch. That means this shear is provided on the punch. How much force you have to apply, that you have to calculate. How you will calculate? By using this particular relation. Okay. So the blanking force you have to calculate. So first of all, you have to calculate the F max value. How you will calculate the F max? The shear stress into sheared area. Anyone got the answer? What is this value?
Sir, over 15,000 Newton.
Those.
You will calculate, you will get some value. I think Jagan has already given the answer. Okay. Now the F max into KT, you know that the work done should be equal F into S plus KT. Okay. Now the F value you can calculate F max into KT divided by S plus KT. Same formula I'm using here. This one. F max into KT divided by S plus KT. K is nothing but the penetration, or whatever the penetration it is given in the question. Now see, it is applicable only when the shear is less than KT. That means the value of shear, if it is less than KT, then you can use this particular formula. Okay. If it is greater than KT, that means this can be neglected in comparison to the S. So you can consider only S. Okay. Let me check first what is the value which you are getting as a KT. So KT value, if you calculate, percentage penetration is 0.4 and this is 3, 1.2. Okay. Now this S is greater than KT because S is given as a 2. You can check in the question itself the shear value which is given as a 2 mm. So that means if you calculate, the force value will become F max into KT divided by shear. This value will be neglected as compared to this one because when S is greater than KT, then you have to consider only shear. So what is this value? Whatever the value which you are getting here, if you divide with the shear value, then you will get the answer 22.608 kilonewton. That means now you can see here, whatever the forces which you are applying previously, now the forces value getting reduced. So this is the application of the shear. That means when you are providing the shear over the punches, that means the value of force is getting reduced. So this question was asked in the GATE 2004. The only thing you have to use that particular formula, then you will get the answer. Similar type, now I am going to discuss one master problem from this punching, or we can say that a blanking or the shear cutting operation. So this is basically two questions are there which is related to the same data. So now what is the question? First of all, in a shear cutting operation, a sheet of 5 mm thickness is given, is cut along a length of 200 mm. Okay, what is this value? The thickness value is given as 5 mm, is cut along a length of 200 mm. The cutting blade, which is the blade which you are using for cutting, which is 400 mm long, that means this cutting blade, and zero shear is provided on the edge. That means the first case I am assuming there is no shear stress, what we call as a zero shear. That means your blade will be like this. Blade means the blade of the punch. Now the ultimate shear strength of the material or the sheet is given as a 100 megapascal and the penetration is given as a 0.2. Okay. So what is the data given? First of all, the ultimate shear strength is given as a 100 megapascal. Okay. So you will calculate F max value. What is the F max value? Shear strength into shear area. How you will calculate shear area? Shear area is nothing but penetration into thickness. What is the shear strength? The shear strength is 100 and penetration, this perimeter. What is the perimeter of this? Yeah, cutting along a length of this one, 200. That means this value is 200. What is the thickness? Thickness value is nothing but 200 into thickness is 5 mm. So you will get as a 100 into 200 into 5, which is nothing but 100 kilonewton. The maximum force which you have calculated at this one. Okay, but what you have to calculate? Assuming force versus displacement curve to be rectangular. Now that means it is a first case only. Now you can see in my theory also I have discussed when there is no shear provided, the force and the displacement curve is a rectangular. Okay. The second one will be the trapezoidal. Now that means it is mentioned that the force and displacement curve to be rectangular means there is a zero shear, or you can also get a clarity when the zero shear is provided. What is the work done? How you will calculate work done? Work done is nothing but the maximum force into KT value. What is the maximum force? 100. What is the K value? K value is 0.2. And what is the thickness value? That is 5 into 10 to the power of minus 3. 5 into 10 to the power of minus 3. But the force value which you are getting in the terms of kilonewton, then you can convert into the Newton. So this value will be 10 to the power of 3. So once you will solve, this will be cancel out. 5 into 0.2 is 1. That means 100 joule of work is needed for doing this particular sheet metal operation. Okay. So this is the first question. That means you are not providing any shear. Now, once you will provide the shear, what will be the next thing you have to find out? That means what is the, when you are providing the shear means the forces you have to calculate. The force value you have to calculate. So this is the second part. The data is same only. The same data, the shear cutting operation, metal sheet thickness, and the length is 200 mm. Cutting blade is 400 mm long. Zero shear is provided. The ultimate shear is, that means the data is, it is a linked type of question. Now the second question based on the given data is, when a shear of 20 mm is now provided on the blade, assuming force and displacement curve to be trapezoidal. This is not required, even they have given. Because once the shear is provided, you know that there will be a curve like this. Or you know that when the shear is provided, that means you have to use the formula in which the shear is given. Now the maximum force you have to calculate. How you will calculate? Because you have the two formulas. The first one is F is equal to F max into KT divided by S plus KT. S plus KT. Where this formula is applicable? When the shear provided, I'm writing here only, shear provided is less than KT value. When shear is greater than KT, then the formula will become F max into KT divided by S. That means the shear is greater than the KT value. That means you can neglect this value as compared to the S. Okay. So first of all, you have to calculate KT value. Here S is given as 20. S is given in 20. But a very important thing, most of the student will do the mistake by considering the shear value. And that is the beauty of this particular question. Because if you take the S as a 20 mm, your answer will be wrong. Then how you will solve this particular problem? A shear of 20 mm is provided on the blade. Okay. So 20 mm, I am providing the shear. 20 mm, I am providing the shear on the 400 millimeter blade. Because the length of the blade, if you see here, cutting blade is 400 millimeter. For 400 millimeter, you are providing the shear is how much shear? 20 mm. But you know that the cutting length is 200 mm. That means, let us suppose this is the sheet metal. If you are cutting, the blade is very big. You are providing the shear over this 400 mm length is 20 in this particular question. But you are cutting only the length of 200 mm. That means you have to calculate for the length of 200 mm, what will be the shear? What will be the shear? So for 20 mm, it is a 400 millimeter. Can you please tell me for 10 mm, So sorry, for 200 what will be the shear? It's a unitary method only. You can easily calculate. Anyone? Yeah, Jagan, you can comment in the chat box also. Both of you. For 400 of cutting
Understood
blade,
this
if
question.
20 shear is provided, if 200 of length you are cutting, how much shear you have to provide? What you will do? First of all, you will calculate for 1 Yes or no? So now, let us suppose for 1 1 so 1 shear is provided on 20 So 20 if the length of blade, so you are providing only 1 But what will be the length of blade? Sorry, the length of cut, which is 200 That means when it will become 200, that means if you are multiplying with 10, so this will be nothing but 20 sorry, this will be nothing but 10 So for 400 you are providing the shear is 20 but for 200 how much you have to apply? 10 This is the main important thing in this question, because the shear is given for 20 for this complete blade. But how much blade is coming in contact? Only 200 no? Because you want to cut this 200 of length. So for that, you have to calculate the shear. So the shear is 10 That means shear is 10 and KT value is 1.2, which is greater than this. Okay. That means you have to consider the second formula. What is this F max into KT? We already calculated, which is 100 joule only. This value. That's why it is a linked question. So 100, what is the shear force? What is the shear value? This is 10. So what will be the answer? 10 joule. Okay. So only thing is you have to calculate the shear value for the given length of cut. For example, let us suppose if I'm considering a 300 length. So you will consider this 300 length for calculating the shear. If 20 is for 400, 1 means just to divide this 20 If you want to calculate for 150, sorry, 300, that means you have to multiply with 15. So that means 15 of shear you have to provide. You have to consider 15 Okay. And these two questions are important. The only thing is you have to use the very carefully the shear value. Is it clear, Jagan?
Yes, sir.
Okay. Now the next thing is one more question was asked in GATE 2018. Okay.
Excuse
The
me, sir.
percentage. Yeah, Raj, tell me.
So in this previous question, which has been discussed now, there is a formula, sir. The F equal to F max into KT divided by S plus KT. Sir, I have to use this formula when some shear is mentioned in any question of manufacturing.
Yeah, when the shear is provided, not manufacturing, when the question is related to the blanking or sheet metal operation. Okay, this question is related to sheet metal, no? This mention. Shear cutting operation means sheet metal operation. Now you have to see if the shear is provided, that means you have to use either this first formula or the second formula. Which one you will consider based on this parameter? If S is less than KT, you have to use this one, because shear is nothing but 10 which you got already, which is greater than the 1 because penetration into thickness is 0.2 into 5 is 1 So S value is greater than KT. That's why I am considering the second one. Got it?
Okay, sir.
Yeah. Now, one more question.
Actually, sir, how I'm asking, sir, this present means
Yeah, yeah. Tell me.
if any other type of question in the sheet metal only, sir, means other type of question in sheet metal where shear mentioned something like this in this question only. And sir, if
Okay.
here if they will mention this force versus displacement curve to be of another type, then another shape like
No, no.
parabol.
Only two types will be there. Okay. Either it is a rectangular or it is a trapezoidal. Okay. It has been observed that the force versus displacement curve you are getting as a trapezoidal when you are providing the shear. Okay. It's not like that you will get a parabolic something. The only thing is whenever the shear is given, okay, then you have to use this shear formula. Or for example, they will mention as a force. Actually, this is the hint for you. But if I will omit this particular part also, you can easily understood. The shear is provided means you have to use this one. Because if the shear value is zero, for example, if shear value is zero, what is this F value? F max only, no? The shear value is zero means KT will cancel out. Got it?
Okay, sir.
Yeah. Now, this question was asked in the GATE 2018. The percentage scrap in the sheet metal blanking operation. Okay, so first you understood what the question was asking. Can you please tell me what is the scrap? Scrap means
Sir, remaining amount of material in any operation means, sir, I will take a sheet metal and in it I will cut, and through it, sir, I will make a, I'll cut in a circular manner in middle, like that, and then I will obtain, and then I will get that my desired shape of circular circular sheet metal, and the remaining material will become my scrap, sir. And also, sir, when I
okay.
cut
So
a sheet metal in
mhm.
specific patterns, the material which is being cutted as well as get separated will also be scrap, sir.
Okay, so in simple language, no need to consider the shape of the sheet metal which you are like product which you are producing. Scrap is basically is nothing but you have a sheet metal. Okay, suppose if you want to make a hole, this hole is basically useful. If this hole is useful means the remaining will be scrap only, no, which is not required. That is the meaning of scrap. That means what is the question? When you are creating a when you are doing the blanking operation means when you are creating a disk shape, okay, then what amount of the material will be wastage? That is the meaning of the percentage scrap in a sheet metal blanking operation. Once you have created this particular portion, how much amount of material is going to be waste? Because the remaining portion, it is waste only, no? This is the useful. This you want. The blanking means this thing you want, the remaining will be sheet metal. It's just like, let us suppose this is the piece of paper. You want to make a hole over this piece of paper, and that is required. Remaining will be scrap only, no? That is the meaning. Okay. The percentage scrap in a sheet metal blanking operation of continuous strip of sheet metal as shown in figure. You have to calculate first of all percentage of scrap. That means you have to calculate how much amount of material will be wastage, okay, divided by the sheet metal, total sheet metal of area. Okay. For that, what I will do, I will use some geometry. So let us suppose uh, this is portion I'm considering. I just want to make a single hole. Okay, for because it's a percentage. So either you can consider one or two or three, it will be same only because you are dividing with the total area. So let us suppose if I'm considering this is the just 1 second. This is basically a one portion of this sheet in which I'm getting a one disk, half of from here, half of from here. Why I have assumed? Because you can see here the dimensions are given here, d by 5. Because I want to calculate from this particular area, if I'm creating a single hole, how much amount of material is wastage. If I calculate this area minus the disk area, you will get the scrap only. Okay. So let us suppose this is nothing but a PQRS will be the rectangle. Okay, fine. What is this dimension? What is this dimension? This dimension, can I write? This dimension is d by 2 plus d by 2 plus d by 5. Any problem? Can I write this dimension as a d by 2 plus d by 5? That means this is d by 2, this is d by 2 because the total is diameter and this is d by 5. Now, similarly, I can calculate this particular dimension, which is nothing but t plus d by 5 into 2. Why 2? Because this is d by 5, this is d by 5. Okay, this is the length, this is the width. Then you can easily calculate the total area. Then you can easily calculate the total area of this particular rectangular cross section. Okay, that means I can write the area of rectangle PQRS is nothing but what is this value? 6d by 5. If you take let me, yeah, d by 2 will become d. So 5d plus d is 6d by 5. And this value will be d plus 2d by 5 is 7d by 5. 7d by 5. Okay, what is the area? 7d by 5 into 5d, sorry, 6d by 5. What is this? 42d square divided by 25. Okay, this is the area of PQRS. Now, what you are making single disk, because half of disk here, half of disk here. So one total disk is you are making. So area of blank is nothing but, what is the area of blank? Pi by 4 d square. Yes or no? Area of blank is this pi by 4 d square. Then you can calculate. So these things you are doing so many times, but if you are calculated for a single one, then the percentage scrap will be same, because you are dividing with the total area. So the percentage scrap or percentage of scrap is nothing but how much amount of material is wastage? The total area minus the blank area. What is the total area? This one. Total area minus the blank area divided by total area. What is the total area here? 40. Okay, I will divide total area. This will become 1 minus AB by 80. That is the blank area. This is the blank area. So 1 minus this value is, blank area is pi d square by 4. So percentage you want to calculate, that means it should be multiplied with 100. 100. So pi d square by 4 divided by 42d square by 25. Okay, so this 42d square by 25. So if you calculate this value, this d square will cancel out. Can you calculate this value? What value you are getting? Do it fast. So once you got the answer, just please text in the chat box. Anyone got the answer? Or I have to solve? What is the percentage of scrap? The percentage of scrap is 1 minus pi square by 4 divided by, sorry, pi by 4 divided by 42 divided by 25 into 100. What is this
Sir, I
value?
got its answer.
Sorry?
Sir, I got its answer. It is 0.467.
0.467. Okay,
Sir,
after
I mean of
subtract.
this pi by 4, this part is there, sir. I have to.
Okay. 0.467 into 100. That means you will get around 53.25. Very good. 53.27 is the percentage of scrap. Very good, Raj. So the correct answer for this question is, and it is mentioned that correct to the 2 decimal places. Okay, so that means 53.27 percentage, because the question it was asked in the percentage scrap. So the correct answer for this question is 53.27. I hope, Jagan, if you solve also, you will also get the same answer.
Yes, sir. I'm following.
Okay, fine. Now, the next question is basically based on the bending operation. So this is also a sheet metal operation. So basically this is a sheet metal. Okay. Now you are applying some forces. Because of the force, the sheet metal get bended. Okay. So what you have to calculate the bend allowance. So before discussing this question, I have already discussed the concept related to this. I just want to give a quick recap of what is bending operation and how you will reach to that formula. So what do you mean by bending operation? First of all, it is a sheet metal forming operation where the metal sheet is bended in a required angle. When you are applying some forces, it is bended in some particular angle. Let us suppose that angle is alpha. Okay. Now, how much stress you have to apply? The stress should be applied in between the yield stress and the ultimate tensile strength. Why yield and ultimate tensile strength? Can we use the stress beyond the ultimate tensile strength? Anyone? Why the stress is only in between yield and ultimate? Okay, I will explain. So you know the already the stress strain diagram. Okay, so this is the yield point, this is the ultimate point. Yes or no? Because of the yield, beyond the yield point, the plastic deformation will be started. And the ultimate point is the maximum value of stress that material can bear. That means if you increase the value of stress beyond this ultimate, the sheet metal will get cut from this particular portion. So you only want to deform this particular sheet metal. That means you only want to bend this sheet metal. That's why the stress should be in between this value. Okay, the yield value and the ultimate. Because if you increase beyond the ultimate, it will fracture. If you take less value of yield below the less value of yield stress, the material will not plastically deform. Only the elastic will be happening. That means the material will regain its original shape, because this yield point is indicating the plastic deformation will start. And bending is basically a sheet metal forming operation, is nothing but a plastic deformation. Okay. Now this is the just a bending operation. Now see, whatever the bending you have done in this particular sheet metal, the same sheet metal I have taken here, I want to calculate the, what is the question? Bend allowance. What is the bend allowance means? There is a formula. The bending allowance means how you will calculate this particular bending length. So let us suppose there is a sheet metal will be like this. Now you have applied some forces and this sheet metal is get bended. Okay. Now this is the inner radius of this, what we call as a sheet metal. This is the neutral surface, the radius of the neutral surface. Now, if you want to calculate this particular value, that is nothing but the bend allowance. The bend allowance is nothing but the length of neutral axis in the bend. That means what is the length of this neutral axis in the bend? You know that if any circle, if you take these 2 points, what is the length of R? R into alpha only. For example, this is R radius and this is the alpha angle. This is the alpha angle. What is the length of R? R into alpha. Yes or no? So, but if you want to calculate the radius of this is nothing but the inner radius R, that means this one, plus K into T. So this K is basically depending upon the penetration. So it may be 0.5, mostly it will be 0.5 only. But when the radius, this radius is less than the 2 times of thickness, then you have to consider 0.33. Most of the time you have to use 0.5 because this R plus, this is the T thickness, this is 0.5 T only. So R plus 0.5 T means K value is 0.5. But first of all, you have to check the radius of curvature is less than 2T or greater than 2T. If it is greater than 2T, you have to consider 0.5. If it is less than 2T, you have to consider 0.33. Okay. That means R into alpha. But if alpha is given in the degree, that means whatever the bend angle is there, if it is given in degree, you have to convert into the radian, because you know that the bend allowances will be in millimeter or some other unit. So you have to convert in the radian, means pi by 180 you have to apply. So this formula you have to use for solving this particular problem. Okay. Very simple problem. I can directly tell you the formula also, but I just want to give how this basically derived. So the bending allowance is nothing but I can write alpha into pi by 180 R plus KT. R plus KT. So R plus KT. Now you can see one more thing. What is this bend angle? Bend angle is given as 1 radian. That means there is no need to convert into the radian also. First point. Second point, the stretch factor, that is K value, is also given. That means this question is very, very simple. There is no need to convert into the radian, already given. So alpha, this value I can take as a 1, because if alpha is given as degree, then you have to convert in radian. So what is the radius? Radius, let me check. Yeah, bend radius is given as 100 mm, and K value, the stretch factor, is given as 0.5, 0.5 into 2. So this value will be 100 and 1. So this means this value is 100, 0.1. So the correct answer for this question is C. C is the correct answer. Choice C will be the correct answer. Okay, so only 2 times the gate framed the question based on this. Okay, the most important thing in the sheet metal is how you will calculate the force value while considering the shear or not shear. Second thing is the rolling, which I have discussed, extrusion, as well as the drawing. Now, the next important part I'm going to discuss, which is called as a question based on metal cutting operation. And this is the most important, or I can say definitely 1 or 2 questions will come from the metal cutting operation. Okay. So before that, I want to tell you what is the metal cutting operation. Till now, I have discussed the metal forming. Metal forming means you are deforming the material. Metal cutting means you are cutting the material. That means the material will remove. The volume should not be constant. For example, let us suppose this is basically a raw material, and this is a tool. This particular angle is called as a rake angle. This is the lip angle, and this is the clearance angle. Okay, this tool you are using, and you are giving the feed velocity or the velocity to this tool toward the workpiece. The material will remove in the form of chips. The material will remove in the form of chips. So this is called as a shear angle, which is denoted with phi. And this is called as a chip thickness, and this is called as a uncut chip thickness. Uncut chip thickness is I am denoting with T. So this T value is uncut chip thickness. TC is the chip thickness. When you are feeding the tool towards the workpiece, the material will remove in the form of chips. Okay. So what are the question they can frame based on this one? The first type of problem they can ask, how you will calculate the shear angle. Second thing is how you will calculate the different forces. Third one is The third thing is how you will calculate the tool life. These are the 3 important sections. So I want to discuss some important problems. And one problem is a master problem from this metal cutting operation, which is nothing but I will cover all the force as well as the how you will calculate the energy and how you will calculate the shear angle in the single problem. But before that, I just want to discuss some basics question so that you will get some understanding of how you will calculate the shear angle and all. Okay, I think these things I have already discussed in my live classes. I don't want to waste the time again how this relation came. The value of chip thickness ratio, which is nothing but, that means cutting ratio is called as a chip thickness ratio, uncut chip thickness and chip thickness. Sometimes they will give you the chip reduction ratio also, that is the reciprocal of this one. Okay, so you will get this particular relation. Tan phi is equal to r cos of alpha, 1 minus r sin alpha. And this is very, very important formula. Very, very important. There will be a 99.99% one question will come from this. Either if it is a 2 marks problem, they will link the problem. If it is a 1 marks problem, they will directly ask the shear angle. Okay. Now, so if you want how this relation came, I can explain. Otherwise, if you know, because those students who have attended my live classes, definitely they know because I have taken from the live classes these slides. If you want, I can explain these things also. Otherwise, I will summarize all the formula, then we will directly solve the problem. Tell me. So whatever the formulas are related to the metal cutting, I have written in one slide. So if you remember those formula, you can directly solve the problem. But if you want, I can explain how this relation is coming.
It would be great if you can give your overview, sir.
Okay, fine. So now the cutting ratio is basically can be categorized. That means they can give you in terms of chip thickness ratio and the chip reduction ratio. So chip reduction ratio. Okay. Now see, T1 is called as a uncut chip thickness. Okay. So be with me for 5 to 10 minutes. Okay, I will summarize all these things so that we will solve some problems. So chip thickness ratio is denoted with the ratio of uncut chip thickness to the chip thickness. That means uncut chip thickness I am denoting with T1 and chip thickness is T2. Now, this is basically a tool. This is the shear angle. This is the chip thickness, which I have drawn here also. So chip thickness, this is the uncut chip thickness. This is the uncut chip thickness. Okay, this is the shear angle. Sometimes if they are giving the chip reduction ratio, that means this ratio should be greater than 1. If they mentioned as a chip thickness ratio, but that value is greater than 1, so always remember they have taken as a reciprocal. But most of the time, they will give you the value individually, uncut chip thickness and chip thickness. Why this is important? Because this R is utilized in this particular formula. Now, how that formula is derived? So I will take this particular triangle, okay, this portion. I think you are able to see my screen. Is this is okay? Anyone? Can you please tell me?
Yes,
Yeah, yes, sir.
Okay. Now see, this is basically a uncut chip thickness. This is basically uncut chip thickness, and this will be the chip thickness. So T2 value. This is the shear angle. So I am zooming this particular portion here. So this is the shear angle. If this is phi, can I say this is 90 minus phi? Because this is phi, total is 90. Okay, this value angle you already know, which is called as a rake angle. This is called as a rake angle. Now, if you consider sine phi over this one, what is sine phi? Sine phi is nothing but in triangle OAB. In triangle OAB, sine phi is perpendicular divided by hypotenuse. Hypotenuse means OB value, this value OB. So T1, this T1 divided by hypotenuse OB. So from here, you got as a sine phi value, which is T1 by OB. Now, if you consider OBC, this triangle, if you consider, now if this is 90 minus phi, this is 90 minus phi, this is 90. Can I calculate this angle? What I'm telling, if this is 90 minus phi, if this is 90, this angle I want to calculate because this angle is alpha. That means the total angle I know 90 minus phi plus alpha, and this is 90. So by using the property of triangle, that means in triangle OBC, can I write this angle plus this angle plus this angle is equal to 180? Same thing I have done here. So I have assumed this angle as a x, 90 minus phi plus alpha, and this angle is 90 is equal to 180. So once you will solve, then you will get x is equal to phi minus alpha. X is equal to phi minus alpha means the angle, this one you got as a phi minus alpha. Now you will consider this particular triangle. You will take as a cos of phi minus alpha. What is the cos of phi minus alpha? This is the base. This is the hypotenuse. Why I have used this particular cos sign here? Because I want to use this value in both the form. That means I want to mention the OB value in sine phi as well as cos phi. Why? Because I want to calculate the ratio of T1 and T2. That is the chip thickness ratio. This OB will cancel out. So the first equation is this, second equation is this. Now, if you divide the first and second equation T1 by T2, which is sine phi cos of phi minus alpha. Okay. Now, what is cos of C minus D or cos of A minus B? Cos A cos B plus sine A sine B. That means cos phi cos alpha, sine phi sine alpha, and this is sine phi only. Now, if you divide this sine phi here, that means it will become cot phi cos of alpha, and this sine phi will become 1. So you are getting this particular value 1 upon cot phi cos alpha plus sine alpha. So cos alpha, this is cot alpha. Cot alpha can I write 10 of phi only, 1 upon 10 of phi, and this is sine alpha. If you cross multiply, what you will get? R cos of alpha 10 phi and R sine alpha is equal to 1. So 1 minus R sine alpha is equal to R cos alpha 10 phi. So 10 phi you can easily write from this R cos alpha 1 minus R sine alpha. This is very, very important relation. Again, I'm telling you, derivation is not important because If the question is coming in the gate exam, you have to remember this formula. But how this result came, that I have explained. Is it clear to both of you?
Yes, sir.
What about you, Raj? You can comment in the
Sir,
chat box
okay, here
also.
the formula is there, okay, sir. But sir, actually, sir, when it comes to formula, sir, I get confused also, sir.
What is the confusion?
Not for this one, but I
No,
present my
that you have to do practice. No, once you practice a lot of question, then it will be retained, because the formula also you have to remember. You cannot derive this. Suppose if you know what is the terminology and how you will derive this relation, that is fine for interview purpose. But even if you are not remembering this formula, you cannot derive in the exam. If 1 marks question is coming, if you are deriving, it will take more than 5 minutes. But 3 minutes you are getting for solving the problem. That's why remembering the formula also important. Okay. And how the result is coming, that is okay. That is fine. Okay. If you solve more number of questions, then definitely, for example, a plus b is equal to, a plus b whole square. What is a square plus 2ab plus b square? How you remember? Because you have practiced a lot. It will come with practice only. Okay, Raj?
Yeah, I got it, sir. Okay,
Yeah.
I
So,
have practiced many questions in this manufacturing of several
yeah.
topics like casting, sheet metal, uh,
Mhm.
machine cutting, metal cutting, machining tool operations.
Okay, so if you have practiced, continue that practice. Okay. I think both of you are writing the gate exam in this 2025 only, no?
Yes, sir.
Yeah. So practice is the very important. Practice as well as revision. Okay. Okay. Now come to the topic. So now the thing is, if alpha is equal to 0, what is the alpha is equal to 0 means cos 0 is 1. So tan phi can be written as R. So sometimes the gate already asked the question, tan phi is equal to, that means they are giving the uncut chip thickness and chip thickness. Then you have to calculate the phi value, which is shear angle. And in that question, they have given that rake angle, that is alpha value is 0. You can easily calculate. Okay. But if you remember this formula, you just put alpha is 0, because they only want to check your concept, not numerical. That's why they have given as alpha is equal to 0. This is the special condition. Now come to the question. Before coming to the question, I just want to discuss one more important thing, which is called as a merchant circle diagram. Okay, so this is the heart of this particular what we call as a chapter, the metal cutting operation, because most of the question they are framing based on the merchant circle diagram. That means there are some formula. Okay, I will summarize all the formula in a single slide. I'm just giving you a overview. So this is basically a tool. This is basically a tool which is used to remove the material. Now, what are the forces involving in the cutting operation? This is basically a cutting force. This is basically a cutting force means this is basically a tool. This is the cutting velocity. So this is the cutting force and this is the thrust force. Okay, this is the thrust force and this is the cutting force. Now see, this basically alpha. Now what is this angle? Shear angle phi. This is the shear angle phi. Now, what are the forces involving? One is the cutting force, another is the thrust force. If you take the resultant, that is nothing but the, I am denoting with R. That is called as a resultant force. Okay. Similarly, if you take this particular tool, if you are cutting this particular material, which is nothing but this one, so chip is moving in this manner. Chip is moving in this manner means the friction force will act in this direction. So this is the friction force. The friction force on this tool in this, then the normal reaction will be here. So again, it will form a triangle. That means the resultant of this force, either you can consider FC and FT. This resultant is overlapping. Again, this is basically a shear plane whose shear angle is phi. What is the shear force? This is the shear force, and this is normal to the shear force, normal to the shear plane. So, how many forces are there? Basically, 6 forces are there. One is the cutting force, another is the thrust force, one is the friction force, another is the normal reaction, and this is the resultant of all 3 pair of forces. Now, if you use the geometry, you will get some relation. For example, I will discuss only two things, then I will summarize all the formula. Okay. And these things I have already discussed. I don't want to invest more time on this instead of solving the problem. So this is the cutting force. This is the thrust force. You can calculate the resultant Fc square plus Ft square. Now, if I want to write down the expression for shear force is nothing but this one. So this is the resultant. The R of cos of this angle is nothing but the shear force only. No? So R of cos, what is the angle? This is phi, this is beta minus alpha, because this is alpha, this is beta, this is 90, this is 90 minus beta. So if you add these three is equal to 90 degree, you will get this is a beta minus alpha. Okay, so beta minus alpha plus phi. If you take the cos component, you will get the shear force. Similarly, the ns, that is nothing but the normal to the shear plane. If you take the sine component of this R, you will get the normal to the shear plane. You got the Fs and Ns. Okay. So if you divide this normal to the shear plane to the shear force, you will get the 10 of phi plus beta minus alpha. Okay. Now, similarly, you can write down for the cutting force and thrust force. If you know the resultant, resultant means resultant of any three pair of forces, any pair of forces. That means shear force, normal to the shear plane, friction force, normal to the this force, normal to this plane. That means F and N resultant, Fc and Ft resultant, Fs and Ns resultant will be same only. So if you take the cos component of R, you will get R of cos of beta minus alpha will be Fc, sine component will be this one. Okay, that means Fc, Ft, Fs, Ns, or similarly, you can calculate the friction and normal reaction. This is R. If you take cos component, then you will get the R of cos of beta, that is N. R of sine of beta is nothing but F. R of sine of beta is nothing but F. So friction divided by normal reaction, you know that friction angle 10 beta, which is equal to coefficient of friction. Because you know that in engineering mechanics also, 10 phi is equal to mu. If the shear angle is given or the friction angle is given, you can easily calculate the coefficient of friction. That means the resultant value F square plus N square, Fs square N square, or Fc and Ft. You can calculate. Once you know one resultant value, you can calculate any forces. Because these angles you can easily derive by using the geometry. Okay. Now I have summarized all the formula in this particular slide. This is called as a master table. I have discussed in my classes also, but I will suggest you please write down all these formula. Then I will move to the problem. So these are the important formula which will be utilized for solving the problem. Okay, so please make a note of it. Then I will discuss the problem. And not in this subject. One thing I also want to suggest you. So any subject which you are preparing, okay, so please make a short notes, or we can say that formula notebook for each and every subject. Okay, so because before the gate exam, like 3 to 4 days before, you can't revise completely. So you need only the formula, because if you have spent 1 year for solving the problem, then it is more than sufficient to easily grasp the formula, because the formula is very important. But if you are not remembering the formula, so it's very difficult to derive, because you don't have that much time. Only 3 hours are there. You have to solve 65 questions. Okay, so please make a separate notebook, or I can say a small notebook, in which you will write down all the formula related to this subject, not in manufacturing or this SOM, whatever it is. For example, in fluid mechanics also, there are so many formula. So before gate exam, you just revise those formula. Or if any particular thing which you are not able to remember, that one also you can write, because the gate is the exam which you are going to write. So whatever the problem which you are facing, write down those things in your notebook also. Okay, so please write it fast. Then I will this is sine alpha 1 minus r sine alpha.
Oh, excuse me, sir.
Yeah, Raj, tell me.
Sir, till now I have given around I have given 4 mock tests, sir.
So can we do one thing? Actually, once this session will be over, so if you have a query regarding like how, sir, regarding the marks and all, that we will take at the end. Is it fine?
Mm, well, okay, sir. The thing is, sir, how many mock tests I need to give before the exam, sir?
That's what I'm telling. This is a general query because this is in the recording mode. More other student will also like watch this lecture. What I will do once this session will be over, that I will take your general query also. Like how you will, I will give you the 5 to 10 minutes. I will summarize how many mock tests is needed. Mostly, if you are asking me, more number of mock tests you can give before 25, 1 week before. Whatever the mock test you are writing, that will be better only. At least if you are giving 8 mock tests, that is more than sufficient. Why the mock test is needed? Because you can analyze the first thing. Second thing is there is a virtual calculator. You also have to make the habit of using virtual calculator. Yes or no? Are you following?
Yes,
Both of
sir.
you?
Yes, sir. I will have a different type of calculator.
No, but in the gate exam, you have to use the virtual calculator, no?
Yes,
Sorry,
sir.
that whatever the calculator which will be in the gate exam, that you have to use. Understood?
Understood, sir.
Yeah. Once you will write the gate exam, if you are writing the gate exam, that means there is a calculator mode also, no?
Sure, sir. There will be a calculator on top right of screen.
Yeah. So that you have to use. So you for solving the problem, if you are using the this scientific calculator, there is a difference. That's why I'm telling. I don't want to interrupt in between these topics. Let me cover the some questions, some important question. So later on, like 5 minutes or 10 minutes, I will discuss those things also. Fine.
Okay, sir. I want you to cover more number of questions now.
That's what I'm telling. No, if you will allow me, then I will cover. No, these general query I will take at the end.
Yeah, okay, sir. Now we can start with the questions, sir.
Yeah, Jagan, have you written this? These formulas?
Yes, sir.
Okay, fine. So, one more important uh, relation in the merchant circle diagram only. So, if alpha value is 0, whatever the things which I have discussed, if alpha value is 0, that means sine alpha will become 0. So, F is equal to Ft. That means the friction force is equal to Ft. This is the special condition. That means if alpha value is 0 means, you can see here, if alpha is 0 means this value is 0. So, it will become vertical, but this will become horizontal. So you will get a rectangle. That means the friction force is equal to Ft, Fc is equal to normal reaction. So sometimes they will give you if the normal the rake angle value will be 0. So these important relation also you have to remember. The cutting force you can directly assume as a normal force. Thrust force is equal to friction force. Otherwise, if you remember this formula, you just put alpha 0, you will get the same answer. Okay, this is the first thing. Second thing, you know the shear stress, the shear stress value will be given in the question. You want to calculate the shear force. The shear force value you can calculate by using this relation also. But sometimes instead of giving those, they will give you the data, which is nothing but the width of cut and the uncut chip thickness. So the shear area if you multiply with the shear stress, you will get the shear force. And what is the shear force? The shear force, if you will divide, shear force, if you will consider from this master table, this one, this is the shear force. If you divide with the shear area, then you can calculate the shear strength. That means sometimes they were asking what is the shear force value by giving the shear strength. Sometimes they are giving the cutting and thrust force. Then you have to calculate the shear stress. So you have to use this particular relation. Cutting force and thrust force is given. Phi value you can calculate, which I have already discussed, 10 phi r cos of alpha. That means these are known to you. W and T1 also they will give you. Then you can easily calculate shear strength. Now the next thing is, what is the power consumption? So during this metal cutting operation, the power consumption means the cutting force into cutting velocity is equal to the total power which you are giving. Some power is basically utilizing for shearing this, and some power basically used in the this one. That means when you are giving the velocity this tool in this direction, so what is the power consumption? Cutting force into this velocity. So then the material will be removing in the form of chips. That means one energy is utilized in this particular region, which is the shear plane, and one is overcoming this friction. Because the chip is moving in this direction, then the friction force is acting in this direction, that will also do some work. So the total force, whatever, or the total power which you are using, that will be divided into two. That is the shear force into shear velocity and the friction force into chip velocity. Now, these things you can easily calculate. And the cutting velocity is also given in the question, but how you will calculate the shear velocity and the chip velocity, that I'm going to discuss. Okay, then we will directly solve the problem. This is the last topic, the velocity analysis. So I have told you this is basically a tool having a rake angle alpha, and this is the shear plane having an angle of shear plane angle is phi. When you are giving the velocity this particular tool, what is happening? So that means the material is removing in the form of chips. Okay. So this is the shear angle phi. This is the alpha. Now, can I make the triangle? So what is the, first of all, shear velocity? Shear velocity is the velocity of chip relative to the shear plane. Velocity of chip related to the shear plane or the workpiece. This is the workpiece only, no? Chip velocity is nothing but the relative velocity of chip with respect to tool, because chip is moving in this direction. So the chip velocity means how they are making a contact with this tool. So the relative velocity of chip with respect to tool is called the chip velocity. Cutting velocity you already know. It is the relative velocity of tool with respect to workpiece. So these three velocity is very important for solving the power consumption. So what is the relation between chip velocity, shear velocity, and cutting velocity? That I will discuss in this one. This is the cutting velocity. Yes or no? Shear velocity in this direction. Shear velocity in this direction. And this is chip velocity. What is this angle? This angle is alpha, which is nothing but shear velocity. This angle is alpha. That means rake angle. Now, this is a rake angle. That means this angle is 90 minus alpha because total is 90 degree. This is shear angle phi. Can I calculate this x value? Yeah. This total angle will be equal to 180. So you will get x is equal to 90 minus phi minus alpha. Now, by using the property of triangle also, this v can be written as, that means v divided by sine of this angle. This is a sine law only. This vector divided by sine of the angle made by the opposite two vector, sine 90 minus phi minus alpha. Shear velocity divided by sine 90 minus alpha, this angle. Chip velocity, if you are considering this velocity, so you have to consider the angle made by these two velocity, which is nothing but sine phi. So cos of 90 minus phi minus alpha is cos of phi minus alpha. Shear velocity upon cos of alpha. Chip velocity upon sine of phi. So once you know the one velocity and the rake angle will be given, phi value you can easily calculate. 10 phi is equal to r cos alpha 1 minus r sine alpha. You can easily calculate the shear and chip velocity. Once you know the shear and chip velocity, if you multiply with the shear force and the friction force, you will get the power consumption in shear, power consumption in during the friction. That means this is also an important formula for calculating the shear velocity and chip velocity. Okay. Now, this question was asked in GATE exam. So what is the question? It is directly based on the formula. If alpha is the rake angle of cutting tool, phi is the shear angle, v is the cutting velocity, vc is the velocity of chip relative to tool, and the velocity of sliding along the shear plane is given by. That means what they were asking, the velocity of shear you have to identify. Can you please tell me which option will be the correct? Just now I have discussed this.
Sir, option A. Okay, sir. If it is VS, then it will be option B, sir. V cos
What about
alpha
you,
by
Jagan?
okay, sliding velocity of chip along shear plane.
Take your time. Why I have taken this problem, then you will understand. Read the question carefully. There is no rocket science in this question. If you read the question, then you will get which velocity you have to find out. So if you want hint, just see this particular relation. Okay. Otherwise, one thing I will do. I will take this particular. At least now you can tell me the correct answer.
B cos alpha by cos omega minus alpha. Option D, sir.
Okay. So Jagan has given the D as answer. So let me explain. That's why I told you, you just read the question carefully. Alpha is the rake angle, no problem. Phi is the shear angle. V is the cutting velocity. Vc is the velocity of chip relative to the tool. The velocity of chip sliding along the shear plane. That means what value you have to calculate? Shear velocity only, no? The velocity of chip sliding along the shear plane. What is that velocity? Shear velocity. Yes or no?
Yes, sir, it's shear velocity.
Very good. Now, so this is basically a shear velocity. This is basically a chip velocity, and this will be the cutting velocity. This is 90 minus alpha. This value you already calculated as 90 minus phi minus alpha. What is this value? This value is alpha, phi. Okay. Now you have to calculate the velocity of shear. So the velocity of shear, or from this particular relation, can I write the velocity of shear is nothing but v cos of alpha sine 90 minus cos of alpha is cos alpha, cos of phi minus alpha. Yes or no? Now see, Vs is nothing but V cos of alpha cos of phi minus alpha. But here it is given as Vc. Here it is given as Vc. So what will be the correct answer? Vc, and this is cos phi minus alpha. Most of the student will do the mistake. This is chip velocity. Here is the cutting velocity. That means you have to use this chip velocity relation here also. What is this V value? Because you know that the chip velocity relation is, can I write from this V, Vc divided by, or Vc cos of phi minus alpha. Just one second. Vc, I want to calculate V. So Vc cos of phi minus alpha divided by sine phi. Yes or no? So now I can put V value here, then I will get Vc cos of alpha sine of phi. This is the beauty. Did you understood what mistake you have done, Jagan? Is this is clear or not? The same formula I'm using, same concept. Here velocity is nothing but V cos of alpha, cos of phi minus alpha. But they have changed the option. Here it is velocity of cutting, sorry, here is the cutting velocity, but they have given chip velocity. So you have to convert in terms of cutting velocity if you want to mention this is the correct answer. So Vc cos alpha, cos of phi minus alpha is nothing is there. That means you have to convert Vc in terms of V. So if you put Vc in terms of V, then you will get V cos of alpha, cos of phi minus alpha. What is V value? Chip velocity, cos of phi minus alpha from here divided by sine phi. This cos of phi minus alpha and this cos of phi minus alpha will cancel out. You will get Vc cos alpha divided by sine phi. Is it clear? This question is clear.
Clear,
Only
sir.
nothing is there. Only you have to manipulate. So in hurry, the student will do the mistake. They will see, okay, Vc cos alpha, cos of phi minus alpha. I already remember the formula. They will not see here it is a chip velocity, not a cutting velocity. Okay, so please make a note of these things also. So whenever you are marking the answer, please read the option carefully. It is a chip velocity and the cutting velocity. Jagan, is it clear?
Yes, sir. Yes, sir.
Okay, fine. Now, I'm expecting at least now you can easily calculate the value of shear angle. I have given you the formula. Just one second. Yeah. Now, I have given you the formula related to the shear angle. Okay, so rake angle is given. Depth of cut, uncut chip thickness is given. And chip thickness is also given. You have to calculate the shear angle. And this question was asked in GATE 2011. Do it fast and tell me which answer will be the correct one. You only have to use the relation of the tan phi is equal to r cos alpha 1 minus r sin alpha. Okay, so I'm giving you 2 minutes. But I want the correct answer.
Sure, there's a perspective.
Anyone got the answer? Okay, now see. A single point cutting tool, the rake angle is given as, that is alpha value is 12 degree. Okay. Now you have to calculate the shear angle. Okay. So in this particular problem, a single point cutting tool with the rake angle is given as 12 degree is used to machine a steel workpiece. The depth of cut, that is the uncut chip thickness, is given as 0.81. Uncut chip thickness means, let us suppose T 0.81, and the chip thickness is given as 1.8. First of all, what you will do, you will calculate the chip thickness ratio, uncut chip thickness to the chip thickness. 0.81 divided by 1.8. If you solve, let me calculate this value. I think this value will be 0.45. 0.45. 0.45. Yeah, correct. 0.45. Now, uncut the chip thickness ratio you got. So 10 phi is equal to r of cos of alpha 1 minus r sin alpha. So you have to calculate the shear angle. What is the r value? 0.45. Cos of, what is this rake angle? 12 degree. 1 minus, what is this value? 0.45, and sine of 12 degree. Once you will solve, then you will get the phi value. Now, can you please tell me what value you are getting? Do it fast. 90% problem I have solved. You only have to calculate the phi value. Just take the 10 inverse of this. Once you got the answer, so please comment in the chat box. What is the value of shear angle? Very simple, no? 0.45 cos of 12 degree, 1 minus 0.45 sine of 12 degree. Are you getting 26 degree? Anyone? Did you got 26 degree? Once you will solve, definitely you will get the 26 degree on it. Okay. So now the next thing is one more question. That is nothing but the orthogonal turning operation is performed on a cylindrical workpiece. This question is also based on the formula which I have mentioned in the master table. 250 megapascal. The following conditions are given. The cutting velocity is given. The feed is given. Depth of cut is given. Chip thickness ratio is also given. Okay. Now the orthogonal rake angle is 7 degree. You have to apply the merchant theory for analysis. The same theory. Shear plane angle you have to calculate, and the shear force. So at least I'm expecting you can calculate the shear plane angle. Do it fast. Okay, I will show you the question. What is the data given? The shear strength is given as 250 megapascal. 250 megapascal. and the cutting velocity is given as 180 meter per minute. Feed is given as 0.2 millimeter per revolution, and depth of cut, that means uncut chip thickness is given, or even the chip thickness ratio is given as a 0.5. The rake angle is given as 7 degree. Okay, so first you tell me what is the shear angle you are getting. Alpha value you know, R value you already know that 0.5, and tell me what is the shear angle. Just now I have discussed. Because in this particular question, you have to calculate the shear plane angle as well as the shear force. Okay, this part I will discuss. But you first you tell me what is the shear plane angle. Which relation you will use? Same relation. Tan of phi is equal to r cos of alpha 1 minus r sin alpha. Okay, so the alpha value and r is given. Tell me what the shear angle you are getting. What is the value of shear angle? Okay, I am giving you 1 minute. Please do it fast. Anyone got the answer? What is the value of phi? R value is 0.5.
Sir, in this question, sir, sir, here how I have to calculate this tan inverse value with in virtual calculator?
So that's why I'm telling you, you have to make a practice. See, in case of virtual calculator, first of all, you have to calculate first of all, you have to feed the angle, then take the tan inverse. Usually, what you will do in the scientific calculator, what we call as a normal calculator, you will take as a tan inverse and then phi value. Yes or no? Or whatever the angle is there. But in virtual calculator, you will first enter the angle, then you take the tan inverse. So if you are not doing more practice, then it will be very problem. That's why I told you, if you are practicing mock test, that means there is a virtual calculator. Solve the problems, at least one or two problems. Even if you know the answer also, make a practice with that calculator. Okay, whatever the value, for example, this value you are getting as for example, 0.5. So first you enter the 0.5 and then take the tan inverse. But in normal scientific calculator, what you used to do, you take the tan inverse, then you will put the angle. Yes or no? Did you got the answer?
Sir, the thing is, sir, actually, sir, in scientific calculator, first I will type a value, sir. Like here, alpha value is there 7 degrees, and then I will select cos or sine, those trigonometric functions. Then I will get answer, sir.
Yeah, then you will get the answer. No, that's why I told you. In case of virtual calculator, you have to put the angle first, then take the cos or sine function. Okay, so these things you have to practice how to use the virtual calculator and all. But still, I have given you a hint. If you are putting the angle, take the cos value.
And in virtual calculator, sir, will there be any inverse values like sine inverse, cos inverse?
Yeah, there is an option, no? You can check. There is a tan inverse option is there.
Okay, sir.
So if you have given the 3 to 4 marks, so did you have not faced this kind of angle? Because you are
Sir,
not writing the same.
actually, sir, till now in the mock test which I have given, sir, I didn't
Hmm.
get any calculation like this of this kind of formulas which has been shown presently, sir.
No, but
Yeah.
at least this cost value you will find in any particular subject. No, either it may be of fluid mechanics, or we can say that it is related to what, because if you are solving the fluid machinery question, then definitely there will be a this cos and sine theta. How you are using them?
Sir, but till now in only in one mock paper I have saw this kind of question, this kind of cost. These are things for only one question of maybe it is of hydraulic machines or engineering mechanics maybe.
Whatever it is subject, I'm not talking about the subject. So one thing you do, whenever at least 2 to 3 hours you spend in the virtual calculator, that will be in the Google also, you will search virtual calculator. Suppose this is the problem, take the same problem, you know the solution. Okay, calculate by using the virtual calculator. So if you are not doing the calculation here, how you will do in the exam? Okay, so leave this thing. The main thing is you have to practice. If you are not practicing, then it will be problem, no? Try to solve more number of questions with scientific calculator. But if you are writing mock test, that means you are not using the scientific calculator. Automatically you have to use that virtual calculator on. So if you write 3 to 4 marks or 5 marks, definitely you will be habituated. But that is needed here before the gate exam. Still, you have more than 20 days. You can, if you write the 2 to 3 mark or 7 to 8 problems, if you will solve, then you will get an idea. Okay. So now the R value is 0.5, cos of alpha is 7 degree, 1 minus 0.5 sine of this particular 7 degree. Once you will solve this 10 of phi, that means the phi is equal to 10 inverse of this value, then you will get as a 26, or sorry, 28 degree, 28 degree. Now, once you know the shear angle, that means either the C option is correct or D option is correct. Okay, so you know that the shear force is nothing but the shear strength into area, shear area. What is the shear strength? Shear strength is already given in the question, 250 megapascal. What is the shear area? BT divided by sine of phi. Okay, you can check my master table formula also, which I have discussed in the starting. So 250, now you can see here, this is the orthogonal operation. So in that one, either this width and thickness can also be calculated by using the feed and depth of cut. Okay, so FD is equal to B into T for our orthogonal turning operation. So 250 into B. B into T means F into T. What is the feed velocity? 0.2. And what is the depth of cut? 3. And sine phi, you already calculated. Once you will solve, then you will get the 320 Newton. Very simple. That's why this is very important. How you are getting the shear angle. Remaining thing is only the formula based. But if you are not able to calculate the shear angle, the remaining part also you cannot solve. Okay, so let me discuss one more question so that you will get some confidence. So this question was asked in the, I think, K 2008. Yeah. So what is the question? Orthogonal turning is performed. I think, yeah, the question which I have discussed previously. So this is also a linked question. That means the same data is given, you have to use to calculate the cutting and thrust force. But how you will calculate the cutting and thrust force? You know the phi value, shear angle. What is the shear angle value? 28. You know the You know the value of alpha? Yes or no? You know the value of alpha, which is 7 degree. Now, some data is given using the merchant theory analysis. Okay, first you read the question. You have to calculate the cutting and thrust force. What is the cutting and thrust force formula? How you will calculate? You know the shear force. Shear force, which is nothing but, which I have calculated previously, this is 320. So the shear force is equal to, can I write R of cos of phi plus beta minus alpha? Yes or no? That means the shear force is known to you. Once you get the R value, okay, once you know the R value, then you can calculate the cutting and thrust force, because cutting force is nothing but R of cos of beta minus alpha. R of cos of beta minus alpha. And thrust force is R sine beta minus alpha. Yes or no? You just see my master table formula. The R of cos of beta minus alpha, R sine beta. So once you know this R value, you just put here. Alpha is known to you. Now the question is how you will calculate the beta. This is very important. How you will calculate the beta? Can you tell me? It is clearly mentioned one merchant theory analysis is there. Based on the merchant theory, the phi value can be calculated as pi by 4 plus alpha minus beta by 2. Or it can be written as 2 phi plus beta minus alpha is equal to 90. So either you can remember this relation or this relation. So this is experimentally it has been observed. If you add 2 times of phi plus beta minus alpha, you will get the 90 degree. But how this shear angle and this alpha is calculated numerically, which I have discussed. So you have to use, that's why it is mentioned, apply merchant theory means you have to use this relation. From here, you can easily calculate beta value. So beta value can be written as 90 minus 2 times of phi plus alpha. Phi you know, alpha is known to you. That means 90 minus 2 into 5. What is phi value? 28. What is alpha? 7. So beta value you can easily calculate as a 41. Once you know the beta value, your problem will be solved. The shear force, you know that. What is the shear force? Let me take the shear force is 320. So the shear force is 320 is equal to R cos phi value is 28. Phi value is 28. What is the beta value? 41. What is the alpha one? Alpha 7. So from here, the R value you can easily calculate. That will be approximately 681.2. 681.6 Newton. So once you know the R value, you just put here cutting force, you can calculate. Beta is known to you, alpha is known to you. And how this relation came, which I have already discussed in my master table. That's why I told you, remember this formula. What is here? Shear force is R cos of phi plus beta minus alpha. What is shear force? The shear force is shear stress into this one. You already calculated this value. You know the R value. So if you know the R value, cos of beta minus alpha is cutting force, Ft is thrust force, this one. So this question was asked in the GATE 2008. Now, one more different type of question I want to discuss. Let me check. If the question is there or not. Okay, first you calculate the friction angle. How you will calculate the friction angle? There are some data which is given. In an orthogonal cutting test, the following data are obtained. Speed is given, depth of cut is given, rake angle is given, chip thickness is given, okay, and cutting force and thrust force is given. Now, how you will calculate the, first of all, friction angle? So you know that 10 beta is equal to mu, that means the friction angle 10 beta is equal to mu means you can easily calculate the friction angle is 10 inverse mu. How you will calculate mu value? Mu is nothing but the friction force divided by normal reaction, because you know that the friction force is mu into n. Now the question comes, how you will calculate this F and N? For F and N, they have given the data cutting force and thrust force. Now, if you see my master table, can you mute yourself, Raj?
Yeah, okay, sir.
Yeah. So the friction force is nothing but, what is the friction force formula? Fc sine of alpha, Ft cos of alpha. Similarly, The normal reaction is Fc cos of alpha minus Ft sine of alpha. Okay, these things I have mentioned in the master table. You know the Fc, cutting force, you know the thrust force, alpha is also given. That means friction is known to you, N is known to you. These two values is known to you means friction, coefficient of friction is also you can calculate. That means beta value is you can easily calculate. Okay. So let me first calculate this value. What is the friction force? Fc sine of alpha plus Ft cos of alpha, and normal reaction is Fc cos of alpha minus Ft sine of alpha. What is the cutting force? Cutting force is 900, and thrust force is 450. This is cos of 7 and sine of 7 plus this is 900 cos of 7 minus 450 sine of 7. So if you solve this, 900 sine of 7 plus 450. Okay. Now the friction value and this one, if you calculate and if you divide this, then you will get the mu value as a, so mu value is equal to F by N, which is nothing but 0.614. If you know the mu value, so 10 beta is equal to mu. So friction angle can be written as 10 inverse of 0.614. So this value will be approximately 31.5. Okay. That means the same formula which I have discussed previously, you have to use that one. So you can calculate the friction angle also, coefficient of friction also. For cutting force and thrust force is given, how you will calculate friction and normal. You can also calculate the shear force and normal to the shear plane. How? Because Fc or Ft is known, then you have to use the sine phi, because you know that the relation between the shear force and normal shear force in terms of Ft is sine phi cos of phi. That means you have to calculate phi, and this phi you have already calculated. This phi, how you will calculate? So 10 of phi is equal to r cos of alpha 1 minus r sine alpha. So they have to give the uncut chip thickness is given. So uncut chip thickness is, yeah, depth of cut is given. So you can easily calculate R value also. So once you know the R value, cos of alpha is known to you, phi you can calculate. Once you know the phi, so that means you can calculate the normal force, normal to the shear force, normal force, shear force, friction force, and the force which is normal to the this tool, which is nothing but N. Okay. Now, so this question was asked in the GATE 2006, the value of shear angle and the shear strain. So shear angle, I think you can easily calculate. Shear strain, I have given the formula in the master table, that gamma is equal to cot of phi plus 10 minus 10 phi minus alpha. Just see in the master table. Phi, once you know, alpha is also known to you, which is given in the question. Rake angle 15, your problem is solved. Okay. So if you want, I can explain this thing, how you will calculate. But I'm expecting at least you can calculate the shear angle. What is the shear angle? R cos of alpha 1 minus R sine alpha. Okay, alpha is given to you. Alpha is 15 degree. Alpha is 15 degree. So how you will calculate R? So R is nothing but uncut chip thickness to the chip thickness, 0.5 to the 0.7. What is this R value? R value is 0.714. Once you know the R value, you just put here, alpha is known to you. What is the alpha value? 15 degree. Okay. So 10 of phi. What is this R? R is 0.714 cos of 12. Sorry, it is a 15. So cos of 15, 1 minus 0.714 sine of 15. So you will get as a phi value is 40.24. That means you got the shear angle. Once you know the shear angle, put in this one, you will get the shear strain. Cot of 40.24 plus 10 of phi minus alpha. What is phi value? Phi value is 40.24. Alpha is 15. Once you will solve, you will get as a 1.653. So what is the correct answer? Choice D is the correct answer. Choice D is the Correct answer. Based on this particular given data, one more question, I think two questions were asked. What is that second question? This question is the master question from complete metal cutting operation, because in this one I have covered how you will calculate the shear angle. Okay, we have solved more number of problems. How you can calculate the shear strain, phi value. Now the next thing is, what is the question? The coefficient of friction. Coefficient of friction means mu value you have to calculate. How you will calculate mu value? Anyone, can you tell me? The mu value you can calculate, it is mentioned merchant theory again. Again, you will use phi is equal to pi by 4 plus alpha minus beta by 2. This is the merchant has given the theory. You can calculate the shear angle value, the beta value from this one. What is phi value? 40.2. Pi by 4 is 45. Alpha is 15. Beta by 2. Now, from here, you can calculate the beta is 24.5. Once you know the beta value, you already know what is the relation between mu and 10 beta. Yes or no? Mu is equal to 10 beta. So, the coefficient of friction, just one second. The coefficient of friction is 10 of 24.5. Once you will solve, then you will get 0.46. 0.46. Okay. The same problem, you have calculated the shear angle, you have calculated the shear strain. Okay. So you have calculated the friction angle as well as the coefficient of friction. Now, the next one is the same data I am taking. The percentage of total energy dissipated due to the friction at tool chip interface. These things I have discussed before discussing the first question. I have told you the cutting force into the chip velocity, or we can say that cutting force into the velocity of tool is equal to this friction force into the chip velocity plus shear force into the shear velocity. Yes or no? The total power consumption I have discussed. If you see, let me take just one second. Just one second. Yeah, this one. Power consumption I have discussed now. The cutting force into the cutting velocity, shear force into this one plus this one. That means whatever the total power which is consuming, it will be equal to shear power consumption as well as the friction power consumption. Now, if I will come to that particular question, just one second. Okay. You have to calculate how much total energy is dissipated due to the friction. Percentage. That means you have to calculate the percentage of energy lost in the friction is nothing but this energy divided by total energy. What is the total energy? Cutting force into velocity. And it should be in percentage, means you have to multiply with 100. Okay. Now, the friction force, how you will calculate the friction force? Because the chip velocity, this cutting velocity is given. Yes or no? Cutting force is given. Cutting speed is given. Yes or no? That means you have to calculate this value. How you will calculate the friction? Friction force is Fc sine of alpha, Ft cos of alpha. That means Fc and Ft should be known to you. Cutting force, yes, thrust force is also given. Okay, so the cutting force is 1200 sine of, what is the sine? Angle is 15 degree plus Ft. Ft is thrust force 200, cos of alpha is 15 degree. Once you will solve, then you will get 503.77. Once this value is known to you, you can calculate the chip velocity also by using the velocity triangle. Yes or no? Chip velocity formula, V sine phi divided by cos of phi minus L, whatever it is. So you know this value, cutting force value is given. This cutting velocity is also given. Once you will put in this one, then you will get the answer as a 30%. 30%. Okay. That means In this question, they have asked you what is the total energy dissipated due to the friction. For example, the same question, that means I want to calculate what is the total energy dissipated due to the shear force. What I will use? This is the energy which is dissipating in the along the shear plane divided by the total energy. So you can easily calculate Fs, Vs value also from the velocity triangle. How you will calculate Fs? You know the formula from master table. Shear force, Fc cos of phi minus Ft sine of phi. So Vs also you can calculate. That means either you can calculate the percentage of energy lost in this one, percentage of energy is lost in this one. Concept is same. They can frame the question in any manner. Okay. Now, one more important thing is there related to the metal cutting. That is nothing but the tool life. Before ending this session, I want to discuss this part also. So you know that if you are doing some cutting operation, the tool is getting deteriorated. Okay, that means the life of the tool getting decreased. Okay, so if you want to calculate what is the life of tool, then you have to use one equation which is called as a Taylor tool life equation. Taylor tool life equation. What is this Taylor tool life equation? V t to the power of n is equal to constant, where V is nothing but the velocity. V is nothing but the velocity. T is the V is the velocity and T is the tool life. T is the tool life and C value will be the constant. C value will be the constant. That means Taylor tool constant and n is the exponent. N is the exponent. So what type of question they can frame based on this Taylor tool life equation? Okay. So suppose if you are doing some cutting operation, some velocity is given, let us suppose some 30. Related to this tool life is 15 minutes. Now, if you increase the velocity as a 15, what will be the tool life? These type of question they are framing. The n value and the c value will be given in the question. Okay. Now, let's try to solve the problem. Okay, the best thing is they have given the Taylor tool equation also. Most of the time they will not give you because v t to the power of n is equal to c, you have to remember. But they have given the equation also, which is Taylor tool life equation. In a machining operation, when you are doubling the cutting speed, it will reduce the tool life as 1/8 of the original one. It is given that when you are increasing the speed, that means the life of tool value will be decreased. Yeah, that is obvious. That then you have to calculate the what is the exponent. What is the exponent? That means v t to the power of n is equal to c. Can I write v1 t1 to the power of n is equal to v2 t to the power of n? It's just like a thermodynamics problem, because you know that in adiabatic process, PV to the power of gamma is constant. How you will calculate some unknown pressure when the volume and the initial state is given? P1 V1 to the power of gamma, P2 V2 to the power of gamma. I think now you are able to correlate. So the velocity, initial velocity, let us suppose if I am taking as a V and tool life I am taking as a T. Now it is the exponent you have to calculate. It is given that you are doubling the velocity. That means you are increasing the speed. That means V2 is equal to 2 times of V. But the Taylor tool life is 1/8 of original one. That means T by 8. So initially, let us suppose tool life is what we can say, for example, 80. Now the final tool life will become 80 by 8. That is nothing but 10 minutes. Okay. So this is the meaning of question. When you are increasing the speed, the Taylor tool life is reduced as a 1/8 of the original one, which is nothing but t. Now you have to calculate n value. This v will be cancel out. This v and v value is cancel out. Now you have to calculate this value. Now a to the power of n is equal to 1, because t to the power of n, t to the power of n will cancel out, which is nothing but 1 only. So a to the power of n is equal to 1. So either you can take log, or yeah, you have to take log only. So n value is nothing but 1 by 3. Sorry, the here will be 2 only. This is the mistake. This will be 2. Now 2 to the power of 1. If you want to take this, what you will do? Can you write? 2 to the power of 3n is equal to 2 to the power of 1. So n can be written as 1 by 3. I have made the base same. So the power value will be 3n. So 3n is equal to 1. So n is equal to 1 by 3. So they can frame the question. They can increase the speed. They can decrease the speed. So if one known parameter is given, second unknown you can easily calculate. Sometimes once you know the n value or the velocity and tool life is given, then they can ask you what is the Taylor tool life constant. That is the C value. Okay. Now the second thing is this question. In a machining experiment, tool life was found to be varying with the speed. I have told you this is the speed, the tool life is 81. When you increase the speed, tool life is decreasing. And it is obvious when you increase the speed, the tool will deteriorate fast. The life of the tool is decreasing. Okay, so what is the question? The question is the exponent n and k value you have to calculate. So can you try this problem? So I'm taking this in the next slide so that we can solve the problem very easily. Okay. So the first condition is given. The second condition is also given. Okay. Use the relation same. Vt to the power of n is equal to constant, which is the Taylor tool life equation. So first and second equation, if you will equate, then you will get n value. Once you know the n value, you can calculate k. Okay. So do it fast. You have to use this particular relation only. Once you know, once you get the answer, please let me know. Otherwise, I will explain.
Sir, regarding this type of question, I have a doubt, sir. Recently, I have many days back, I have practiced a question in which two cutting speeds and two tool lives are given, just like in this question only. But what
Correct.
they have asked is, they have asked in third case, like what if the cut? I didn't remember, but I remember that if that means they have given both tool life and both cutting speed, and then after that, what they have asked is, if the tool life is eh, maybe no, so it's if the cutting speed is around 120 meters per minute, then what will be its tool life, sir?
Right.
Means what they have given first and second values just like in this question only, and when
Mhm.
it comes to third case, sir, they have given only cutting speed, and they are
Only
asking for
one,
life.
I think only one parameter they have given. You have to calculate the either tool life or velocity. That is the question, no?
Sir, but in that question, sir, I have saw on its solution, sir. What actually they have done, sir? They have find
No,
out
no,
the
I will
value of
explain.
N and
Uh,
C from the first case and second case, and then what they have done, sir, for this third case, they have equated to second case, sir. Means V2 T2 power N equal to V3 into T3 to the power N. But
Correct.
what I have done, sir, I have equated with first case, sir. V1 T1 power n equal to V3 T3 power n. And it became wrong, sir. Why, sir, it is like that?
No, it will not come wrong. I think you have done some mistake. See, the thing is, for example, if anything like Vt to the power of n is equal to constant. Okay. So if you are increasing the velocity, the tool life value will be decreased. Are you agree? Yes or no? Because to making a constant, if one parameter is increased, other has to be decreased. So you can write V1 T1 to the power of n, V2 T to the power of n, V3 T3 to the power of n, V4 T4 to the power of n is equal to C. You can take any combination. Then now the question is what you are asking. So the two parameters is given, the first and second one. So from there, I think you have calculated the n value. Once you know the n value, then you have calculated the C value. Yes or no? These things you have done?
Uh, yes, sir. In that question, I have done this thing. First, I have find out
Okay.
N and C.
Yeah, let me explain. Once you know the n value and C value, okay, either you can use this one, because this is equal to C only, no? Now, the third condition is, let us suppose the cutting speed, I am increasing 120. So I can ask you what is the Taylor tool life? How you will calculate? Once you know the n and C value, can I write like this? V3 T3 to the power of n is equal to C. Now the C value you can easily calculate by using the knowing the value of n. So let us suppose C value is something 120. So V3 it is also given. Yeah, but V3 is also given. Now you can calculate the T3. So they can frame complete table also. They can ask the third, fourth, fifth, you will get the same answer. That's why I'm telling you, just try to attempt this question. Once you know the n and k, you can calculate the velocity and the tool life in any cases. Suppose if I'm giving you the tool life, you can calculate the velocity. It is the reverse method. No? I think you have done some mistake. It won't be wrong. Once you cross check your calculation, V3 T3 to the power of n, once you know the n and c value means Taylor tool life constant value you have to keep. N value is known to you, C value is known to you. If V3 is given, you can calculate T3. If T3 is given, you can calculate V3. Okay, so first you tell me what is the N and K in this particular case. Both of you, Jagan as well as the Raj. Please do it fast. Otherwise, I will explain. Very simple problem. It's not difficult. V1 T1 to the power of n, V2 T to the power of n is equal to constant. Okay. So what is the data given? The
Sir,
V1
option
velocity is
A.
given as 60. Yeah, Jagan, let me check the option A is correct or not.
Okay, sir.
So V is 60. T1 is 81 to the power of n. V2 is 90. T2 is 36 to the power of n. So this is nothing but 1.5. 81 divided by 36 to the power of n. So if you take the log, n log of 81 divided by 36 and log of 1.5. So from here, you will get the n value. Let me calculate this value. 1.5 and this value. Yeah. N value you are getting as a 0.5. So only one option is there. You can easily mark the correct answer A. But let's calculate the K value also. Okay. So V1 T1 to the power of n is equal to K. So what is the velocity V1? Okay, so either you can consider this V2 T to the power of n is also K. You will get the same answer. So V1 is 60, T1 is 81 to the power of 0.5 K. So 60, this is nothing but 81 to the power of half. That means, can I write? This is 9 only. So K value is 540. Very good, Jagan. Your answer is correct. Okay. So any parameter, for example, if I'm giving you the next tool life, you can calculate the cutting velocity. Is it clear, Jagan?
Yes, sir.
Okay. So now